Hello friends, this video on Communication Systems Part 8 is brought to you by examfear.com. No more fear from exam. So for now, our next new term is bandwidth. So I'm sure you are able to understand each of the terms which I have been explaining so far. Okay, so let us start with bandwidth. What is bandwidth? So let us see what is bandwidth. Maybe you would have heard this term in day-to-day life. You would have heard of people talking about bandwidth of different radiations. So what exactly is bandwidth? Now, it is the difference between the upper and lower frequencies of a band of electromagnetic radiation. So while we were discussing the lesson on electromagnetic waves, I talked about the electromagnetic spectrum. You remember? Right, where we have different types of radiation. We have ultraviolet radiation, we have infrared radiation, we have the visible light, we have radio waves, microwaves. So we have different types of radiation and they are classified into different types based on their frequencies. Right? Now, different type of radiation will have a certain range of frequencies between which they will operate. So that range of frequency is known as the bandwidth, right? So it is nothing but the difference between the upper and the lower frequencies of a band of electromagnetic radiation. So each signal will have a specific range of frequencies. So when I say I'm talking about an audio signal or I'm talking about a video signal, so each of these signals has a specific range of frequency, and they might overlap, but they might not overlap as well. So each of them will have, let us say, if I say there is some signal which operates between 1 kilohertz to 10 kilohertz, that means so what is the bandwidth? Now, if I have a signal which operates between 1 kilohertz and 10 kilohertz, so what is 1 kilohertz? It is the lower frequency. What is 10 kilohertz? It is the upper frequency. And what is the bandwidth? Bandwidth is upper frequency minus lower frequency. That means 10 minus 1. That is 9 kilohertz. Right? So that is our bandwidth. Now, examples of different signals, when we say it may be audio signal, it may be video signal, it can be a speech signal. So each of them will have a different range of frequencies. So when I talk about audio and video signals, the first things that come to our mind is a television or a radio or even a computer. So each of them will use signals of different bandwidth. So let us look at the bandwidth of some signals. The type of communication system needed for a given signal depends on the band of frequencies which is considered essential for the communication process. So now if you want to set up a communication system, so you will set it up for a particular type of signal, right? So you have to consider whether you want an audio signal to be communicated or you want a video signal to be communicated. So depending upon the type of signal which you want to be communicated, you have to decide on the band of frequencies. So it is very much essential to have an idea about the bandwidth, because depending upon that you will set up the entire communication system. For example, when I talk of the speech signals, their frequency, their bandwidth falls somewhere around 2800 hertz. Similarly, for music, it is 20 kilohertz. For video, 4.2 megahertz. TV, 6 megahertz. And all of these fall within this audible range. What is the audible range of frequency for a human ear? It is 20 hertz to 20 kilohertz. That means any frequency which falls within this range is audible to a human being. We can hear them. And anything which falls out of this range, we cannot hear them. Right? So if you see here, speech, audio, everything, music, everything falls in this range, and that is why we can hear them. Right? So similarly, each and every signal will have its own range of frequencies, and it is very, very important to have an idea about that range of frequencies so that we can construct a communication system accordingly. Now, the way different signals have a bandwidth, similarly, different transmission medium also have bandwidth. Because when I talk about a communication system is not only about the signals to be transmitted. It is also about the other essential components of the communication system, be it the transmitter or the receiver or the channel. And what is the channel? The channel is nothing but the medium. Right? So the bandwidth, so even that transmission medium also has a bandwidth of its own. Now you might be wondering the example which I took of that letter. So you might be wondering the channel was the rails or the air. So they do not have a bandwidth. That might be a question in your mind. But now you think of some real life examples of communication systems. Whether you think of the telephones which we use at our homes, or you think of the computers. So what do you think? What do you generally see connecting the different devices? We often see wires. However, these days we also have the wireless technology. But normally we see wires, cables. So what are they? They are nothing but transmission medium, and these transmission medium also have a bandwidth of its own. So these medium also operate only between a certain range of frequencies, and it is very, very important to have an idea of that range as well. Let us look at some of the transmission medium. Wires and cables, which are very commonly seen. Fiber optic cable for optical communication, or if I talk about so here you can see the fiber optic cable here. In this picture, it is very well demonstrated. Or if I talk about free space, even a free space acts as a transmission medium. Now, how do the transmission happens through free space? It happens by propagation of electromagnetic waves. Right? We have already spoken about electromagnetic waves in a previous lesson. So we know how electromagnetic waves propagate in a medium. Right? So these electromagnetic waves, maybe radio waves, they propagate through free space. So this for radio waves to propagate through free space, they operate somewhere between few kilohertz to few gigahertz. So that's the frequency range in free space. Similarly, if I talk about wires or cables, so when I talk about cables, I'm basically talking about the coaxial cables, which look somewhat like this. The internal structure looks somewhat like this. So at the center, you have a central axis, and on top of that, you have two rounds of wires. So that is a coaxial cable. So these wires or cables also operate somewhere around 750 megahertz. So that is the bandwidth of the wires or cables. When I talk about the fiber optic cables through which optical communication happens, so these fiber optic cables, they operate somewhere between 1 terahertz to 1000 terahertz. So you see, they are all different range of frequencies in which these different type of transmission medium operates. Right? So bandwidth of the transmission medium as well as the bandwidth of the signal, both of them play a very important role in a communication system. So if we want to construct a communication system, we need to have an idea of the range of frequencies of the signal as well as the transmission medium. Now, a question that might strike any of your mind is that when we were talking about the basic diagram of a general communication system, we never talked about frequencies. So suddenly, from where did the frequencies come into picture and they play such an important role that we need to know the bandwidth? Well, you remember when I talked about the transmitter. So what was the transmitter doing? It was basically converting the non-electrical signals into electrical signals. And then those electrical signals were sent through the channel. Now, how do you think those electrical signals are getting transferred through the channel? Now, those electrical signals are nothing but they are getting propagated as electromagnetic waves. So those electrical signals get converted to electromagnetic waves, and the propagation of electromagnetic waves happen through that medium. right? So now for this propagation to happen, you should know the frequency of the medium through which the wave is propagating, and you should also know the frequency of the signal which is propagating. So when there will be a mismatch, effective communication will not take place. You would have seen that with all the devices which you have, for example a radio, you always see an antenna with a radio. What is the purpose of that antenna? So that antenna basically catches the signals. So how does it catch the signal? It catches the signal with the help of frequency. So this device will have something which will actually match, whose frequency will actually match with the frequency of the signal. So when it matches, it catches. And you are able to get the information. And you are able to hear songs or any other program which is coming on a radio. So frequency plays a very important role, and antenna is one of the best examples which you can think of in order to understand how frequency is involved in a communication system and why do we need to know the bandwidth of a signal or a transmission medium. Right? Okay. Well, you will get more idea as we go ahead with the lesson. You will get to know more and more. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.